Hi there, and welcome to today's video. My name is Joshua, and I am part of Group 22 for Assignment 2. Today, my group members and I will be presenting our work for Assignment 2 of the Software Evolution and Maintenance subject. For the first part of our assignment, we were asked to propose a unique system that our team would be maintaining. We chose to develop MediTrack, which is a hospital inventory and patient assignment system. Unlike the movie store system we'll be discussing later in this video, MediTrack is a specialized enterprise resource planning, or ERP tool, and it is designed specifically for the medical care sector. Its main goal is to bridge the gap between medical inventory management and direct patient care. Practically, this means hospital staff can track real-time stock levels of critical supplies, like pharmaceuticals and other surgical equipment, and automatically allocate those resources to specific patient records as soon as a treatment is administered. On top of that, it manages the logistics of patient room assignments and doctor scheduling to keep the hospital running smoothly.
To build on to what Joshua said in the overview of our proposed system, MediTrack, let's look at the specific users that we have identified for it. As we can see in this table here, we have identified three main groups. The first one being the medical staff, which consists of the doctors and the nurses. Their primary goal, or their primary role rather, is operational. They're the ones who are inputting patient data into the system, and they're also the one to be requesting supplies for treatments, which includes the reports that they will need about certain patients in order to know how to treat them. The second ones are the inventory managers, who focus more on the supply chain side of things. They use MediTrack to monitor real-time stock levels of pharmaceuticals, and they are then responsible for processing procurement orders when the stocks are running low. And finally, we have the system administrators, and they manage the technical backend, such as configuring user access rights, and also the ensuring that the system is configured correctly and remains stable. With these three groups working together, it bridges the gap between inventory management and patient care.
I'll be picking up from where William left off. I'll be discussing the first two requirements that represent the baseline capabilities of the MediTrack system upon initial deployment. So the first function requirement is FR01, Patient Record Management, and this requirement allows medical staff such as doctors and nurses to create, view, and store digital patient profiles. These profiles will contain essential information such as basic medical history and contact details. From a maintenance perspective, this feature is critical because not only is the patient data long-lived, meaning it grows continuously over time, but it also directly influences the data storage, the performance, and the future maintainability. Thus, function requirement 1 forms the core data entity of the MediTrack system and many later maintenance concerns like data growth and archiving, which will originate from this requirement. For the second function requirement, the FR02, inventory tracking, it ensures that the system maintains a real-time count of the medical supplies, including pharmaceuticals equipment. Inventory managers can also manually update stock levels, and this requirement helps introduce continuous transactional data, frequent database updates, and strong dependency on database performance.
So, I'll be covering on functional requirements 3 and 4. So firstly, in functional requirements 3, the resource allocation is actually a feature that allows nurses to link specific medications or equipments used during treatment directly to the patient's digital record. So imagine this could help with nurses who are administrating, let's say, a vaccine to a specific patient. Well, with this feature, the nurse can actually record how much of that vaccine was used and from which respective batch that vaccine was from, directly to the patient record at the specific time frame. Now, this creates really a clear trail connecting inventory usage to the individual patient care. Could be helpful for multiple reasons. Firstly is accurate billing, allowing the patient to be billed for the resources that they use. And also it could help the inventory managers within the hospital to also accurately track and predict consumption patterns within the hospital. Next is the functional requirements number 4, which is actually staff scheduling. So the staff scheduling feature provides a centralized calendar for hospital administrators to assign both doctors and nurses to specific shifts and departments. So instead of managing the schedule through traditional, let's say, spreadsheet or paper roster, administrators can now use this single interface to see who's working where and when. This could be really helpful for ensuring schedule conflicts do not happen and ensures that coverage is good across all departments and the different times of the day, and to ensure that hospital operations are able to be maximized and run at its utmost efficiency.
Picking up where Justin left off, I'll be discussing the last 2 requirements of the MediTrack system that we are proposing. So the 5th requirement, room assignments, involves having the system track the occupancy of hospital rooms and also allow for the staff to assign patients to whatever available vacant beds there are. And the 6th and last requirement, search and reporting, involves having the system providing a search interface to allow for users to retrieve a patient's full history regarding the medical history, medication, all that, using their unique patient ID.
Moving on to part B for question 1, we'll be discussing and analyzing the different maintenance scenarios and justifying the maintenance activities for each one. So firstly, I'll be discussing our first scenario regarding a change request. Currently, the MediTrack system requires inventory managers to manually check stock levels at the end of every week, which directly correlates to FR02 in the requirement table above. The hospital administration found this inefficient and submitted a change request 001, to automate this process. They want the system to automatically trigger an email notification to the procurement department whenever any specific medication drops below a safety threshold of 50 units. This ensures that critical supplies never run out during an emergency, which is really important. So it will replace a slow manual process with real-time monitoring. With all these different scenarios in place and the change requests being identified, for question 1C, now we need to classify the maintenance activity using the decision criteria tree. So first and foremost, let's look at the automated low stock feature alert for change request 001, and let's run through the decision criteria tree carefully. First we ask, was the software changed? And the simple answer is yes. This request isn't something we can solve through simple user training. We have to actually modify the system's behavior to handle these new alerts. Additionally, the current system simply doesn't have the capability to monitor stock levels autonomously and automatically, so a direct modification to the software is required, and there's no way going about it without adjusting the software. Second, was the source code changed? And again, the answer is yes. Implementing an automated email trigger requires our team to write new logic within the backend, like editing Java or Python classes, to monitor those database thresholds, and to create the trigger and also integrate it with the email server. So it's much more than just a documentation update. Finally, was the function changed? And here, the answer is yes also. We are introducing a brand new business rule. If stock is under 50, then send email, for instance. So this is a new feature that enhances the system's original scope. So in other words, by adding the automated alert, we are expanding what the system actually does for the user. Therefore, this is classified as Business Rules D3 Enhansive Maintenance.
To scenario 2. In this scenario, we're dealing with a performance issue. As the hospital gained more and more patients, holding over 500,000 records in the database now, it takes now up to 45 seconds to load a full report, to generate a report. Whereas in the past, when it was first introduced, it was very fast. This is a detriment to critical decision making in the ICU, and as such, the medical staff decided to contact, or rather make a change request to the maintenance engineers, aka us, to make a change to the database query so that the report can be loaded in under 3 seconds without any data in the report being altered in any shape or form. So the data that's been retrieved for the report should be exactly the same as is, whilst loading in under 3 seconds. As we can see down here by the change request details, name of the request being query optimization. The change request description is essentially just a scenario, and the change reason, as we have briefly mentioned already. The impact of the change is that because the new database needs the database requires new indices to be created. So because of this, there may be a downtime that is required. So there's a time where the database may be inaccessible. So this is one of the impacts that needs to be documented to let the hospital know. And also the other impact is that we may need to do a full regression test to make sure that optimization of the queries does not accidentally change the data that is being retrieved, since we don't want any of the data in the report generated to be different from what it was originally. And we have some proposed actions that can be done, such as analyzing the SQL execution plans to find what the bottlenecks are, implement indexing to the patient ID and other relevant columns, especially ones that are used very often. We might need to refactor the backend to have proper caching by using something like Redis to use memory RAM to cache the data for a fast key to key value pair database. We can also conduct load testing to ensure that the response time is indeed loading in under 3 seconds, even under high traffic, as required by the change request. Using this evidence-based decision criteria tree here, we can identify that this is a C3 performance change request. And we can identify this very simply by following everything in this tree here, starting at A. The question to start is, was the software changed? And this is a clear yes. For starters, we are not going to be training doctors to wait longer. That is not a viable or realistic option, because the life of patients are in the hands of the doctors. They need to be able to make decisions quickly based on the reports that are generated, to make quick and fast decision. So we can't just train the doctors to wait longer. We need to change the software in some way to make it faster and optimize it. So we need to move on to block B. Was the source code changed? Is another clear yes, because, well, we need to change the source code in order to update the SQL queries or add indices to the database to optimize the speed at which the system can retrieve data. So we're not just updating documentations, we are changing the source code, which puts us to block C here. Was the function changed, however, is no. The reason why that is the case is because we need to ensure that the system still generates the report as it was already. So the data that's been retrieved should be exactly the same. The report generated should be the same. The only difference is that it needs to be faster. So it is not enhansive, it is not corrective, and it's not reductive. We are moving to C3 performance because we're increasing the performance by optimizing the database queries. It's not adaptive because in this specific scenario, nowhere was it ever mentioned that we are putting it into a new environment, into a completely new environment. We're not doing that. It was not mentioned anywhere, and we are not doing preventive maintenance either, because we're making changes based on some form of requirements. We're not trying to prevent something. We're trying to improve something that was requested, and it's not grummative because we're not optimizing code structure or refactoring anything. We are instead making the performance better, and thus we are in C3 performance.
And now I'll be discussing scenario 3, which I have provided right here. So in this scenario, there is an issue in the MediTrack system where whenever a user retrieves data records from the database that's connected to the hospital system, then more often than not, it'll end up being one record short of the intended amounts that is expected to be retrieved from the database. And therefore, this issue is causing a lot of problems to the users, let's say to medical staff who wants to retrieve a group of patients' medical history, or inventory managers who wants to keep track of whatever stock there is of medical supplies, but always ends up being one record short, so it's not really that accurate. So the system administrators send a change request to the IT department in order for the bug to be urgently fixed. This change request has been issued on the 18th. Change description is roughly the same as what has been explained here, but added on that it had a fix to the bug within the code has to be made. It will be described within the change request details that when the system retrieves data from the system database, often returns one less record than what is expected. And this is the change reason. Again, fix critical bug. Impact of change is to fix the critical bug within the system, as well as ensuring that all data records from the database from now on will always return the correct amount of data records expected. Post action is to go through the code for the system functions and API that enable the request data records. And whenever the bug is found, the faulty code will be edited and fixed to remove the bug. And lastly, once the bug fix is done, testing will be done to ensure that the bug is fully removed from the system. Now I'll be talking about the main type of maintenance activity that scenario tree is considered to be a part of. And in order to do that, we have to go through the decision criteria tree in order to find what classification that the maintenance activity or scenario tree is, which is shown here to be Mrs. Rules C2. So how did we arrive to this classification? First, we need to check whether the software was changed during this change request, in which, yes, it was, because we have to go into the code to fix a bug that's happening to the system, and by proxy, this also means that the source code changed. Yes, we have to fix a bug within the code in the system. And there was function change. Also, yes, the function to this because the function to retrieve data from the database has to be changed in order to fix the bug. So yes, the function was indeed changed, and therefore this considers the change request to fall under business rules, and more specifically, as mentioned before, corrective maintenance activity. Reason for this is that the change request details that the bug urgently needs to be fixed in order for the important feature to work properly. So it is correcting a fault within the system rather than adding on more features to the system or reducing functionality.
So right now I'll be covering a little bit on scenario 4, which is actually a cloud infrastructure adaptation change request. And we see that in this change request, the MediTrack actually runs an on-premise Windows server from 2016 right now, using the local MySQL 5.7. And however, the hospital actually wants to migrate to a cloud-based system. In this case, would be Microsoft Azure, as part of a wider governmental healthcare digitalization mandate. And this has to be done so by Q2 of 2026. And what's going to happen here is that the change request is actually requires the adaptation of the current application to work with Azure SQL databases. But what this entails is that converting MySQL specific queries that now exist in the existing system to change it towards a TSQL syntax, and also to factor in the containerization of the application using Docker to be deployed within the Azure deployment. And the important thing to note is that within this change request, all existing functionality remains identical and similar. So the system still manages patients, tracks inventory, and the schedules accordingly. But the only thing that changes is the operating environment of the specific system. Alright, so let's look at the decision tree for scenario 4. Well, firstly, we will have to see whether the software itself was changed. And yes, the software was changed as the application actually had to be modified to work in Azure environment, moving from the existing on-premise database. Now, when we look at the second part, was the source code itself changed? And the answer is still yes, as the database connections and MySQL specific syntax had to be updated towards a more modern TSQL syntax. Well, this required significant changes towards the back end of the application, resulting in source code also being changed. And as we look at the last part, was function change? The answer is no, as users still perform the same task with identical outputs. However, the main change that is experienced here is mainly linked towards the cloud environment, and that is why, as we look at the decision tree here, the functionality isn't changed. So let's quickly review this. According to the table here, yes. So we can see that the decision tree is a yes, yes, no. So if we were to go down this, was software changed? The answer is yes. Was the source code changed? Yes. And then for the final one, was functionality changed? No. And that's how we actually end up with C4, adaptive maintenance under. So we can see it's labeled as adaptive maintenance, and partially in some way, the key distinction is that we're not really adding features or fixing bugs, but we're simply ensuring that our system continues to operate within a new cloud environment.
So as you can see here in scenario 5, after reading all of this, the MediTrack system, in summary, is currently operating correctly. So there are like no system failures, user reported bugs, or performance complaints. But the system administrators have observed that patient records, treatment logs, and inventory transactions are never archived, and all data continues to accumulate in the primary operational database. So the internal monitoring indicates that the database is steadily growing, which poses a future risk of not only performance degradation, but also increased query latency, and also alludes to the potential system outages during peak performance hospital hours. Thus, this situation has triggered a preventive change request. The change request is formally documented as request 005, titled Database Preventive Optimization, and was requested by the system administrators. The change involves introducing automatic archiving of inactive patient records, improving database indexing, and refactoring the backend data access code. But it is also important to emphasize that there will be no functionality changes, no user workflows will be altered, and no retraining is required. Because the goal is purely to improve the internal system quality, reliability, and long-term maintainability. The proposed actions also include things like stress testing to validate system stability under future data growth scenarios. Now, let's move on to the decision criteria tree for this change request. Based on the decision criteria tree we see here, we can ask a few questions. Firstly, was software changed? Yes, because the internal database structures and backend code must be modified. So now we can move on. Was the source code changed? Yes, because the changes involve things like refactoring, indexing strategies, and archiving mechanisms. So we can move on. Final question. Was function changed? No, because the users that interact with the system, they interact with it the exact same way as before. So since the functionality remains unchanged, we move into the software properties branch of the tree. And finally, since the purpose of the change is not corrective, as no faults exist, not adaptive, as there is no environment change, and not perfective, as there is no features, but is instead to reduce the probability of future failures, it is classified as C2, preventive maintenance.
Moving on to question 2, I'll be discussing part A, where I'll explain the maintenance performed on the movie store system to transition from figure 2 to figure 3. There were actually two main changes that were involved transitioning from figure 2 to figure 3 in this question. The first part involved optimizing the algorithm for speed. But in order to identify the maintenance activity, let's quickly run through the decision criteria tree to ensure we are correct. Firstly, A, was the software changed? And in this case, yes. The user interface and expectations regarding speed required a direct intervention because the latency was inherent to the algorithms themselves, which weren't too great. So it could not be fixed through external means like training. Next, B. Was the source code changed? And in this case, yes as well. We physically replaced the algorithm implementations. Specifically, the bubble sort logic was replaced with insertion sort, and the linear search was replaced with binary search. C. Was the function changed? And in this case, no, not at all. While the internal mechanism was improved, the functional task remains identical. The system still sorts a list and still searches for a title. The inputs and the outputs are exactly the same. So in conclusion, this is a software properties C3 performance maintenance. Because the only thing that changes is the non-functional property of execution time, and in this case, it was actually improved. Next up, we have the second part, which involved the request to show the number of movie titles. So let's run through the decision criteria tree again. Part A, was the software changed? And in this case, yes. This demand for a new functional capability, which was viewing total inventory count, required a direct alteration to the software artifact to handle this exact data. B. Was the source code changed? And again, yes. The new logic was added, specifically the movie store size variable, which increments during the addition of movies, along with the system outprint F statement on line 39 of figure 3. C. Was the function changed? And again, yes. Unlike the sorting optimization, this introduces an entirely new functionality. The system now performs a task, which is counting and displaying total volume. So this is also a feature that the system was previously incapable of doing. And in conclusion, this falls under Business Rules D3, Enhanced Maintenance, because the system has been expanded with new features to enhance its utility for the user.
Now I'll be explaining question 2b1, which is the control flow graph and how it was drawn. So this is the figure tree, which is the control flow graph was based on. So I'll start from block 1, which are these lines of code, which will execute one by one. Then I'll go to block 2, which is this while loop. And inside the while loop, if it's true, we'll execute block 3, which is these 4 statements here. And keep on looping, and when it's false, it will break out. It'll go to block 4, which is this print statement here. Then it will go to block 5, which is the for loop. And inside the for loop, it will keep on executing this print line statement, which is block 6. When the for loop is false, ends, it will go to block 7, which is the next for loop here, the insertion sort. And inside the for loop is block 8, which is these 2 statements here. And then next will be block 9, which is the while loop. And inside the while loop, if it's true, it will keep on executing these 2 lines of code, which is block 10. And when the while loop is false, it will break out and go to this line of code here, which will execute. Then it will go back to the start of the for loop, which is block 7. And when the for loop ends, it will go to block 12, which is this print line statement here. And then I'll go to block 13, which is this next for loop. And it'll keep on executing this print line statement here. And when the for loop ends, you'll go to block 15, which are these 6 lines of code. Then it will go to the next while loop, which is block 16. And inside the while loop, as long as it's true, it will first execute this statement here, which is block 17. And then I'll go to block 18, which is the if statement here. And if this statement is true, it will go block 19, which execute these two lines of code, break out, and go block 24. And if block 18, the if statement here is false, it will go to the else if statement. And if the else if statement is true, which is this line of code here, block 21, it will loop back up to the while loop again. And if an else if statement is false, it will move on to block 22, which is the next else if statement. And if that is true, it will execute this line of code here. And if it's false, it will just go back up to the start of the while loop again, block 16. And the while loop is false, it will also go back down to block 24, same as when the if statement is true. So now, in block 24 is another if statement, down here. And if it's true, it will execute this print statement here. And if it's false, it will go to this else if statement here, which is block 26. And if it's true, it will execute this print line statement here.
Let's now take a look at the data dependence graph, or PDG, that is derived from the maintained code as well as the CLG that was discussed just now previously by Rohan. I'll open this in an image viewer so it's a little bit easier to follow than the Word document. So our criterion here for the PDG is the movie store size variable, and it is last used in this line here in the basic block 15, where it outputs the movie store size. We can see that this arrow here goes up, which is the data dependence, and because it depends on the data that was reassigned in this basic block 3, where movie store size equals to movie store size plus 1. Because if the value of that changes and then outputs later on, then we are dependent on this line of code. And well, this line of code also is dependent on itself, because movie store size is equal to movie store size plus 1. So this code itself relies on its own value to be able to add 1 to itself. So it depends on its own data, so it has to loop back to itself. We can also see that the red arrow also goes all the way up to the initialization of the variable, where it says int movie store size equals 0. This is very important. Firstly, it's because we now know that the data type is an integer. It's not a float or double, boolean. It is an integer. It has to be an integer, and now we know what the data type is. But more importantly, we also know that it is equals to 0. That means that we can start, when we start adding, we're starting to add from 0, and it will become 1, 2, 3, and so on and so forth as more movie titles get added into the system. So that's why it's dependent on that database, on that movie store size data variable initialization. But down here, there's a lot more going on here, because the movie store size itself has a control dependency, which is this while loop here in the basic block 2, where it requires that the new movie title is not equals to end. If it's equals to end, then this loop won't run. So this line of code is dependent on the condition of this block here. So it has a control dependency on that. But that control dependency has a variable of its own, which is new movie title. So without that new movie title, this control block won't run. So that means our PDG, our program here, is dependent on the value of new movie title as well. Well, to be dependent on that means we need to depend on when the input of new movie title was at. So, which is new movie title equals input.next. which takes in the input of the user. And this input specifically here, this line of code here, is dependent on the line just before it, which is defining the scanner for the input. Without that line of code, we cannot do an input from the user. So that line is also very important. Thus, there is a data dependence arrow to the scanner initialization. And it is also dependent on the initialization of the new movie title variable itself as well, because it lets us know what data type this variable is going to be. It lets us know, lets the system know that this variable here is a string. It's not going to be a boolean, it's not going to be an integer, it's not going to be a float or double, it's going to be a string. And that's why it's important for us to include the initialization of the variable as part of our slice that is going to be generated from this PDG. And now the new movie title also depends on the data of the new movie title equals input.next inside of the loop itself, which is the block 3. Because without including this as part of our slice of that is dependent as a part of the data dependence, thus our slice, the loop will go on indefinitely because, well, this variable will always equal to something that the user has input at the beginning. So it will always be not equal end. So we need the user to input again to change the value of new movie title. And as such, inside the loop, we need that next input. And which is why that line of code is also important. Of course, that means that this line of code here is also dependent on the control flow. Dependent on the control flow of the while loop itself. Without this while loop, this line of code cannot be executed, which is why we have a blue arrow or a control dependence arrow that leads us to block 2, basic block 2. Finally, there's one more very important arrow that we have to address, which is all the way down here in the output. We have a movie store size here, but we are all going all the way back up to int movie store size equals 0. Why is that? Is actually very simple. Because if the user inputs new movie title as end as their first input, that means that this block 2, and block 3 never gets executed because it now equals end. Because this equals end, the loop itself will never execute. If it never executes, then the next time movie store size get executed is at the output. Well, movie store size needs an initial value to be able to output something, and that initial value is where the variable was initialized as an integer equals to 0. That is why that red arrow is an important data dependence arrow that tells us that is a slice that is required. And that completes the PDG and this PDG will thus allow us to generate, or rather find, the program slicing that is required.
Now I'll be talking about how the slicing is done within this PDG. So first, since we are searching for slicing related to this movie store size variable by way of backward slicing, we first need to find the last occurrence of this variable within the PDG, which is in block 15. Block 15 over here. So after we find which block it's in, we put in the line which this variable occurs in within this current slice array to help keep track of what our slice looks like right now. So initially we only have line 39 here. So after finding the last occurrence of this variable, we have to find all the blocks that contain other instances of this variable that will most likely affect the last occurrence of movie store size. So it is found that line 6 and 15 in blocks 3 and 1 are part of this slice. So we go ahead and add them into the current slice array. So as block 3 is the closest block to block 15, and we are doing backward slicing, block 3 will be analyzed next. And within this block 3, it's analyzed that the movie source size variable is dependent on itself, as well as again in block 1, which is the same as block 15 here. And then what I mean by dependent on itself, block 15, this variable here is dependent on this variable here, in which is dependent on itself, movie source size. So yeah. So we can go. So no change to the slice yet. And when we analyze block 3, we actually can see that block 3 is part of a while loop. So within the while loop, there's only one line of code in. So we just put that line of code in because it's part of the slice. And the condition of this while loop, new movie title, we also have to find like which lines of code is the data dependent on that affects the flow of this while loop. So it's found that lines 13 and 18 are part of the slice, so we add them in. And first we analyze the new movie title variable within block 3, because block 3 is within the while loop. And within block 3, we find that it is dependent on a scanner input function variable, which we find to be defined in block 1 as seen here. See this new movie title input.next is dependent on this scanner input. And then since there is no more, we find that no more lines are dependent or are part of the slice, we can go to block 1 where we analyze the block from bottom to top, starting with the new movie title variable, which is also found to be dependent on the same scanner inputs definition as the new movie title variable in block 3. So we can move on for now. And through this analyzing this block, we also find that there is a new movie title variable definition as well in block 7. So we add that, go ahead and add in the slice. And lastly, the movie source size variable that block 15 and block 3 are dependent on is the first occurrence of movie source size within the code which defines this variable. So it's not dependent on other data, and there's no change to the final slice. So the final slice would be 6, line 6, 7, 12, 13, 14, 15, and 39.
So in the last part of question 2, we'll be actually having a look at the figure 3, and we'll be looking at maybe what requires some maintenance. Maybe it's been manipulated or changed, and for example, it's showing the wrong output. So we'll be actually exploring the code and seeing what requires maintenance and the before and after the maintenance. So very quickly, let's have a look at the binary search case sensitivity bug. And what's happening here is that the users are actually reporting that when they search for a specific movie, the system actually freezes and doesn't really give the result. And there's actually this critical defect that is resulting in users not being able to search further. So it's related to case sensitivity. And looking at this problem, we can see that insertion sort and the binary search actually uses the compare to ignore case for navigation. And this is not the issue. This produces the right results. They're able to find it. They're actually able to navigate to the right position and actually find the check. The problem actually occurs later on in the binary search with the equal. So we can see here with the equal, that's actually where the problem happens, because that one is case sensitive. And this also means that so for example, I have a quick example here. When the user adds some things like a Minecraft movie, but searches it in lowercase, that's where the error occurs. And as we can see here in the faulty code, the equals actually is when maintenance is carried out, that is changed to ignore case. And so the type of maintenance that we're performing here as per the decision tree is actually the corrective maintenance, because it actually fixes the fault found in the business rules, in this case the search function. So I think having looked at that, let's move over to the code. So in the binary search here, I've highlighted it here for us. In this part, this is the faulty code. So let's just quickly give it a run. And then as we can see, let's just say we quickly put test, and then test 1. Okay, and then let's just end it. So we can see the movie is listed here, but when we were to, let's say, search for test, it doesn't show up. The error continues further here. As you can see, we're stuck in an infinite loop. So even though if we were to put the right answers, we don't get the thing. And what we actually have to do is end the program. So let's just quickly do our maintenance here. So let's first remove the faulty code. Then let's quickly remove this as well. Comments, and we should see that the code has been fixed. Let's run the program again. So if I were to put test and test 1, and then put n, and then now if I were to put test, we can see the movie can be found. So yeah, that's the maintenance that has been carried out. And now we can see that after making the changes, we are no longer stuck in the infinite loop.